So here we're going to find the indicated term of this geometric sequence. We're going to find a sub 1, so I'm going to use my formula here. A sub 7 equals, my a sub 1 is 5 times my common ratio is 3. Why is it called common ratio again? You divide to find what the rule is. So, and a ratio is represented by division. Okay, n matches that, 7 minus 1. So 5 times 3 to the 6. Times 5, and I get 3,645. Number 6, I want to find a sub 6. A sub 6 equals, the first term is 16 times your common ratio of 1/2. 6 minus 1, so that's 16 1/2 to the 5th. Well, if I raise 1/2 to the 5th, you're going to raise the numerator and the denominator to the 5th, so that's 1 over 32. Well, 16 times 1 over 32 would be what? 1/2 is your answer. So remember, this is arithmetic because it has the common difference in it. This is geometric. It has the what in it? The R, common ratio. Do you see how to tell the two apart? You're so bored in this unit, aren't you? I know. Don't worry. Second semester makes up for everything. Second semester is one of my favorites now. You learn stuff you never learned before. All right, let's turn over to page 6. We're going to look at 9 and 10. I don't like number 8. All right. Now this is your sum formula. Write that on your card. That's your sum of a geometric sequence. That's the last. You got 4 formulas. Here's your other ones. Geometric's not on your quiz tomorrow. A model student would have said, Mr. Hester, since I left my notebook somewhere, do you have an extra copy where I can write this down? Gary, you got joy in the real world. You know what I'm saying?
There's no book bags.
What now? What you say?
But there's no book bags.
And there's no note takers. So, you could have just got a piece of notebook paper out.
Oh, wow. It's in my book bag.
There's no one in your group? You just get a whole nother hat. All right, number 9. So we want to find the sum of the first 15 terms. So I'm going to put S sub 15. The A sub 1 is 5, parentheses, 1 minus. We got to find our common ratio. How do you figure we're going to find our common ratio? Take the second one and divide it by the what? And what is the common ratio? Let's put that in parentheses, negative 3. Raise it to n. The n over here is 15. Divided by 1 minus a negative 3. Now, I'm going to do all this in the calculator and be done with it. Watch this. First, I'm going to put negative 3 in parentheses, like that. Now, I'm going to say 1 minus what I just got. Okay, you know how to use your answer key, don't you? Like, that's my answer right here. I just said 1 minus that because answer's right above the negative sign, if you did not know that. So I brought that down. Then I'm going to times it by what? 5. And this is a double negative, so I'm going to divide it by what? 4. So my answer is 17,936,135. And Miss Fisher, that's a large number. Remember, we're multiplying by 3, so if you're going up to 15 terms, those numbers are about to get really large really quickly. All right.
17.
Did you put the -3 in parentheses?
Yes.
Okay. Let me know what you get, and I'll come back and help you. Find the sum of the first 7 terms. S sub 7 equals A sub 1 is 8. Parentheses 1 minus, how do I find my R? 4 divided by 8, which is what? 1/2. Don't put 2 there now. Remember, the second one's got to come first. 4 divided by 8 is 1/2. 1/2 raised to the 7th. 1 minus your common ratio of 1/2. So I would do 1 divided by 2 raised to the 7th. 1 minus what I just got. Use the answer. Times 8 divided by 1 minus half is 0.5. So you get 15.875.
Okay, can you help me with this? I have no idea why.
Come on. Did y'all get something different on number 9 than I did?
No, I got something.
You're doing 8. You're on number 9.
Yes.
Yes. Look at it now. Thank you, Emma, for 7 days, because I was wondering what's wrong with my... We're on number 9. We're doing 9 and 10, Jack. All right. Are there any questions on that? Pretty easy, isn't it? All right, let's start our last lesson. Let's turn to page 7. We're going to learn today how to evaluate a binomial coefficient. Guys, the only time you're ever going to use this is if you take AP Stats. So I just got to introduce it to you. This is the only time you will see anything. This is, I mean, honestly, don't use this much, but still got to teach it to you. So we're going to do a couple of these and then move on to something else. Binomial coefficients. If you see something like this, 6/2, they want you to evaluate this binomial coefficient. The formula for this, guys, is n factorial over r factorial times n minus r factorial. No, you don't write this on a note card because I'm going to teach you an easy way to remember this. All right, what you do, guys, is you put the top number on top. N is your top number. R is your bottom number. And then you just subtract the 2. 6 minus 2 is 4. That's how I remember it. Put the top number on top with a factorial. Bottom number on bottom with a factorial. And subtract the 2. Now, when I go to simplify this, I'm going to start off with 6 times 5 times 4. Do I need to go past 4? No, because the 4 is going to cancel out. So I'm going to do 6 times 5 times 4 factorial. All right. What happens? These cancel out. What is 2 factorial? 2 times 1 is what? 2. What's 6 times 5? 30 divided by 2 is? That's your answer. So on number 2 here, you put the top number on top, bottom number on top, and subtract. What's 4 minus 4? What happened to these 4 factorials? I'm left with 1 over, because you got to put something there. What's 0 factorial equal to? So your answer is 1. What goes on top of number 3? 9 factorial. What goes on bottom? And then 9 minus 3 is 6. So I got 9 times 8 times 7 times 6. I'm going to stop at 6 because these cancel out. 9 times 8 times 7 gives me 504. 3 factorial 6. I get 84 as my answer. Are y'all good on those? Okay, we're done with note takers today. Your homework only deals with it reviews arithmetic and geometric. Now we're not done with class. I want you to go and mark your homework. Page 9, 25 through 35 odd, and page 10, 1 through 13 odd. And then we're going to look at a famous triangle. Yes. We're going to look at a world famous triangle right here. Pascal's triangle. Mathematician Pascal discovered this relationship. And tomorrow we're going to use this to expand binomials. So I want to kind of talk about this triangle tomorrow instead of using, because it's kind of a hard concept for some people to grasp. So we're going to take our time on applying this tomorrow, but I wanted to just talk about the triangle today. You will get to use this triangle on the test. So you get no part of this triangle. I want you to look at the first part of this triangle and try discovering the pattern. What do you notice about a pattern? Take them, don't say it out loud, take a moment just to look for a minute. Talk in your group about it. Alright. Someone share with me what you notice. First of all, what's on the outside of the whole triangle? 1. Okay, we got that. Now, tell me how you think they're getting the other numbers. Like right here, 1's going to be all the way down, but then 1 plus 1 is what? 1 plus 2 is? 2 plus 1 is? Put a 1 down. Now add 1 plus 3 is? 4. 3 plus 3 is? 6. 3 plus 1 is 4. Put a 1 down. 1 plus 4 is, we'll go right here, 5. 4 plus 6 is? 6 plus 4 is? 4 plus 1 is? Put a 1 down. 5 plus 10 is? 10 plus 10 is? Oh, I got off. Oh, Mr. Hester made it. What's 1 plus 5? 6. 1 plus 5 is 6. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Next, 1 plus 6 is 7. 6 plus 15 is? 15 plus 20 is? 20 plus 15 is? 15 plus 6 is? 21, and 6 and 1 is 7. Okay, let's keep going. 1 and 7 is? 7 and 21 is? 28, I mean. Yep. 21 and 35 is what? 35 and 35 is? 35 and 21 is? What is it? 21 and 7 is? 28 and 8. Keep filling that out till the bell rings. So we're going to use Pascal's triangle to expand binomials tomorrow. And when I mean expand, look at me for just a second. Look at me for just a second. Tomorrow what we're going to do, you know those, let's say we had a binomial, x plus 3y to the fifth power. X plus 3y to the fifth power. That would take a long time to multiply and distribute all that out with, because you have to write it 5 times with me. Well, you can use this triangle and do it in one step. And that's what we're going to do tomorrow. Is how we're going to take that binomial, instead of having to multiply it all out, is use this triangle to figure out what it is. There's a pattern to it. And the mathematician that came up with this, discovered this relation, is called Basil Pascal. He was a European mathematician.
Either from Germany or France. He was one of the two.
Oh, thank you.